We will solve a question from GATE 2021 Mechanical Engineering Set 2. Question number 14. It says a plane truss PQRS where PQ is equal to RS, angle PQR is 90 degree as shown in this figure. The forces in the members PR, slant member PR and vertical member RS respectively are. The options are F root 2 tensile and F tensile, or F root 2 tensile and F compressive, or F compressive and F root 2 compressive, or is it F tensile and F root 2 tensile. So we need to find the forces in the members PR, internal forces in the members PR and RS. As we know, we will start with finding out the external reactions at these supports. Now this can be done using two equilibrium equations. It is either summation FH equal to 0, which says that sum of all external horizontal forces in the truss or in the system is 0, or summation of moment at point P, at around any point it is 0, we can use at point P conveniently is equal to 0. Because the truss is in static equilibrium, these two equilibrium conditions are satisfied in the truss. In fact, summation of vertical forces is also 0, but we will not use this equation because there is no vertical external load on the truss. In this video, we are going to solve it using summation FH equal to 0. Now let's mark the unknown reaction towards the right first, that is positive, and let that be HP. As per the equilibrium equation, if we write the summation of forces, it is HP plus F equal to 0. These are the horizontal forces in the truss, so we have written those and summed them up. So HP is equal to minus F. We have got this force as minus F using the equilibrium equation. Now next step, once we got this force, we can use the joint method to find out the forces in members. Which joint should we start with? Is it R or is it P? It should be P because there are only two members connected at P, and it is easier to find out these lesser number of unknowns. We will just draw the FPD of P and see what are the forces acting at joint P. Obviously there is this reaction force. It's minus F, so we'll just reverse the direction and write it plus F. The other forces, which is force in member PQ, there is this force at 45 degree in member PR, which we need to find out, and this angle we know it is 45 degree. Now again applying summation FH equal to 0 at joint P. This is joint P. At joint P we will apply again summation of all horizontal forces is 0. Which are the horizontal forces in this at this joint P? It is nothing but the component, horizontal component of this slant force FPR. So we can write it is towards the right, so it will be positive FPR. Horizontal component will be sine 45 degree. And this is towards the left, so we will write minus F is equal to 0. These are all the horizontal forces at joint P. Hence, from this we can find out FPR to be F upon sine 45 degree. After putting the value of sine 45 degree, we have F upon 1 root 2, and which amounts to root 2F. Now what is the sign of this force? As we have assumed it to be positive, that is towards the right, and we have got the answer positive, it should be towards the right, that is away from the joint P. So this is the direction, and we can write it to be tensile. The force is away from the joint, so it is tensile. We have got our first answer, that is force in member PR is root 2F, nature is tensile. Now next we will find out the force in member RS, the vertical member RS. In order to find this force, we go to joint R and consider the free body diagram there. So let's see which are the known and unknown forces at joint R. at joint R, we have the external load F, we have this member force, that is FPR, acting at 45 degree from the horizontal away from the joint. Then the unknowns are obviously the force in member QR, that's FQR, the force in member RS, which we need to find out. And is there any other force? We'll check it. No, there is no other force. Now, as we need to find the vertical force here, we will apply the equilibrium equation that says summation of all vertical forces is 0. And when we write the summation root 2F, now this angle is 45 degree, we knew. Sine 45 degree is the vertical component, but it is downwards, so it should be negative. And then we have the force, we have assumed it to be downward, so it is also negative, minus FRS is equal to 0. Now finding out FRS from this equation, FRS is equal to minus root 2F, and sine 45 value is 1 by root 2 again. We'll just cancel out root 2, and we get it to be minus F. So we have considered it away from the joint. It turned out to be negative, so the nature should be compressive, that is towards the joint. F compressive. So we have our answer. In member PR, we have the force as root 2F tensile, and in member RS, we have it as F compressive. Our answer is option P. For more details about joint method, you can refer to NPTEL course Lecture 8 Trusses 2 Engineering Mechanics by Professor K. Ramesh, IIT Madras. I hope you understood this solution. Thank you.